Right, let's start. Now, first question. Now, which one decreases as the substance is heated from solid to gas? Now, first of all, let's revise, okay, arrangement. All right, so if you look here, this is solid, this one is liquid, this is a gas. Talking about arrangement here. Now, remember arrangement, there are two parts to read. Okay, can everyone type into the chat, how do you describe the arrangement of particles in solid? So for solid, right, it will be very what? Can someone either unmute yourself or type into the chat? Thank you very much, Nicole. So very closely packed, not just closely packed, but very closely packed. That is the first point. Then there is a second point. In what? Most students keep forgetting to write the second point. Thank you, Javier. They are organized neatly. So we either say in an orderly, either you learn the word orderly or you learn the word regular, up to you. All right, either orderly or regular arrangement. So when the teacher mark this question, I mean, if I change this to open-ended question, there'll be two ticks, you know. Most students only have half the mark. All right, so arrangement. Caitlin, you talk about vibrate, about their fixed position. Very good, but then that is then motion. All right, so if I'm talking about arrangement, it's just these 2 points. If I ask about motion, it will be they will vibrate. All right, and then the second point, how do they vibrate? They vibrate about fixed position or around fixed position. So they all have fixed position for particles in a solid. Okay. All right, so that is for solid. Let's move on to liquid. So for liquid, right, I'm going to change to blue. So this is liquid. So for liquid, can someone type into the chat? Let's type into the chat. So instead of very closely packed, you will change it to what? Anyone? Just remove the first word. Very closely packed, just write closely packed. Now you need to remember all this because if it comes out in the open-ended, you have to write it this way. For the second point, so I have the first tick already, closely packed. In what? Anyone? Unmute yourself or use a chat, please. Oh, sorry. Accidentally moved the slide. All right, anyone? In what is the opposite word of orderly? Hi everyone, what's the opposite? Okay, Nico say random. Disorderly. Oh, hang on. Disorderly. All right. So learn the word orderly. You know, like you're queuing up in straight lines at the parade square or during your school assembly. So learn the word disorderly. Okay, so there are 2 points. Okay, then for motion, for movement, then you write particles in a liquid, they slide, all right, over each other. All right, they slide over each other in a random way, that's fine. All right, so again, there are 2 parts to read. Okay, so please learn the word orderly and disorderly. All right, then here is very closely packed. Okay, just add one more word. Here is just closely packed. Okay, here is very closely packed. Just add one more word here, very. Oops, I think I shall change it to, all right, just very. Okay, now how about particles in a gas? Shucks. Okay, wrong instrument. Okay, this way. All right, can everybody type in the chat? How about gas? I'm going to use maybe this time round purple. So for gas, okay, for gas, are they closely packed? No, they are not closely packed. They are far apart. So that is the first part. Then the second bullet, in a what? Orderly or disorderly? Because I can have far apart and then they queue up, you know. This is also far apart, but then they're queuing up as though they're in the parade square. But gas particles don't look like that. All right, gas particles don't look like that. They don't queue up. orderly. So what's the opposite word of orderly? Would be in a disorderly. Now, some of you ask random. It's fine. Random and disorderly is about the same thing, okay? In a disorderly arrangement. All right, or you write irregular arrangement or random arrangement. All right, so take note that everything that you see here, there's two ticks for the, if I'm going to separate this, all right, so the top part is on arrangement, the bottom part is on motion. All right, so I go back to purple. How about for gases? How do they move? They move very what? Okay, they move freely, they have the freedom, and they move at high speed. All right, so like expressway like that, like the cars traveling the expressway, they're very fast. Gas particles are very fast, and then they move very fast. They move at high speed in all directions, anywhere. All right, some go up, some go down, some go left, some go right. So every direction, they have the freedom to move in all directions. And when they move, they don't move slowly. Freely just means they go all direction. Freely is the same as all direction. Freely comes from the word freedom. Freedom means some particles go up, some particles go down, some particles go left, some particles go right, anywhere, any direction. So in all direction, freely. But you still must tell me the speed at high speed, all right, or rapidly also can. All right, so again, there's 2 points here. All right, so 2 points, 2 marking points for arrangement, 2 marking points for motion. All right, everyone clear? So most of the time, students, if this is an essay question or open-ended question, you all don't get full marks because you always give half the answer only. Okay, let me check anyone in the meeting room, waiting room. No. Okay, so going back to this. All right, so I'm going to write, maybe I'll just make sure you all don't get mixed up. This is liquid. Okay, the blue one is liquid, the purple one is gas, and the red one is solid. Okay, so I'll change to highlighter. So this is far apart and disorderly. Right, so those highlighted words, all these are for arrangement. All right, then those that I did not highlight, okay, those maybe in blue, all these vibrate about fixed position. Sorry, not fixed particles, I spelled it wrongly, fixed position. Oh, okay, pen. Okay, so I have fixed position, just like the classroom, you have a seat plan. All right, so then slide over each other, high speed, all directions. All the ones in blue are the arrangement. Right, so do not get mixed up. Okay, so all these are the arrangement of particles, and the bottom one is motion. So there are 2 things here. One is talking about arrangement, one is talking about motion of the particles. All right. So back to the question, when I'm heating a solid to change to a gas, what is actually happening? Is the speed of particles, now they are saying decreases, so speed actually go faster, right? From solid to gas, all right, speed will go up. All right, so A is wrong because I'm looking for something that go down. All right, decreases means down. Then distance between the particles. Now you see that at first they are very closely packed, and then later become closely packed. Just now it's very, very closely packed, then becomes closely packed. Then for gas is far apart. So the distance between the particles actually go higher. All right, so it actually went up. Okay, so this is wrong. I'm looking for something that go down. Okay, then next, temperature of the substance. All right, when you're heating it, of course the temperature go up. So this is also wrong. So the answer is number of particles per unit volume. So answer, this is D. All right, so answer is D. Okay, so if you were to look at my laser pointer, in a solid state, imagine every atom is 1 gram. So this solid in this amount of space, in this per unit volume, volume means space. If you count every atom, let's say it's 1 gram. So 1, 2, 3, 4, 5. So 5, 10, 15, 20, 25 gram. If I put this solid on a weighing machine, let's say there are 25 atoms. So let's say it weighs 25 grams. Now I talk about a gas. In the same amount of space, same space is the same volume. Same volume means same space. I have 1 gram, 2 gram, 3 gram, 4 gram, 5 gram. I put the gas on a weighing machine, it only weighs 5 grams. If I put a solid on a weighing machine, it weighs 25 grams. So heavy. Solid is heavier than a gas. If you are talking about in the same volume. Per unit volume means in the same volume. Per 1 unit of volume. Volume means space. All right, so gas particles, because they are far apart, so you only have 1, 2, 3, 4, 5 atoms, let's say 5 grams, so only 5 grams. All right, so the number of particles, over here, number of particles, there are 5 particles. Over here, I have 25 particles. So it's true that the number of particles in the unit volume, it goes down. All right, so let me write it here for you. So here let's see, I have 25 particles. All right, in the solid. But in the gas, I have 5 particles only in the same volume, in the same space. All right, so volume means space. So it's true that the number of particles, it go down less. Right, any questions so far for the first question? Right, if not, let's go on. All right, now metal expand when heated and metal contract when cooled down. All right, so which one is correct? All right, so over here, what is actually happening is when you heat up. Okay, so let me make sure it's on the right. Okay, let me draw this. So let's say I'm drawing up, let's say over here. Okay, 3 particles. Okay, or maybe I'll draw solid first. Okay, so in a solid state, all right, I should actually join them together. Okay, let me redraw. Okay, hard to control the pen. Okay, I draw 3 here, same size, all right. I try my best to draw the same size. So this is solid state and it's taking up this amount of space. All right, so this is solid. Okay, when I heat it up, these 9 particles, so there are 9 atoms here, or rather I use 9 particles lah. Okay, 9 particles. When I heat it up, does it mean the particles become bigger size? Does it mean that? Does it mean the particles become giant size? Do I draw 9 of these? No, right? So remember, particles do not grow fat. Okay. Anyway, please don't use fat on human beings. Okay, no one is fat. Let's all love our body size. Doesn't matter big or small. All right. So particles do not get fat. I can use fat on particles because they are not human beings. All right. So instead, what is happening is when I heat it up, okay, when I heat up, the space is the same size atoms, the space. All right. So 1, 2, okay, maybe I'll draw them slightly apart. 2, 3, all right, 4, 5, 6, 7, 8, 9. So the amount of space that is taken up, right, is actually, or maybe I make it more exaggerating lah. 4, 5, 6, 7, 8, 9. All right, so the amount of space taken up is more. All right, from a small box become a big box. All right, so the volume, all right, go up. Okay, the volume go up. Okay, but the size of the atom remains the same. Size of atom is the same. All right. Then why is the volume go up? Is because the space between the particles go up. There's more space now between the particles. All right, go up means increases. Okay, so for question 2, right, the particles are further apart when heated. Okay, and then when it's cooled, right, it's closer together when cooled. Right, so the answer is B. So always remember, particles do not change size. The particle size is the same. What is the one that changes is the space between the particle. Here, there's very little space between the particle. Here, there's